With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Magnetic field B is confined to a region r less than or equal to A and points out of the paper r equals 0, being the center of the circular region. A charged ring means a charge is having the charge is Q, the radius of the ring is B, and the mass M lie in the xy plane with its center at origin. And now the ring is free to rotate and is initially at rest. Now the magnetic field is brought to 0 in time delta t. So you are supposed to find the angular velocity omega of the ring after the field vanishes. So when you are taking it out, you are supposed to find the angular velocity omega after the field vanishes. Now we will say that let E be the electric field generated. Okay. So if E is the electric field generated around the charged ring for radius B. Okay. So if radius B of the ring in which the electric field is generated, then you can say that the flux E is the EMF E is equal to d phi by dt. And according to the Ampere circuit law, we know that E dot dl is equal to b pi a square by delta t. And when you rearrange it, dl, when you are substituting, dl is the length, that is nothing but the radius. When you are substituting it, you will get the equation as E into B is equal to b a square by 2 into delta t. So let this be one equation, and now if it starts rotating, there will be a torque produced in it. And so we know that torque will be equal to the force into perpendicular distance. So the force, we will write it as QE because it's of electric field. So force is equal to Q into E into perpendicular distance is B. So you can write this as, in place of E into B, Q we will retain it as it is, E into B we will substitute this. So it becomes QBA square by 2 delta T. This will be the torque present. Now this torque will be equal to, you can say it like, in the numerator you can take this whole thing QBA square by 2 as delta L divided by delta T. So when it is rotated along with the torque, you will have an angular momentum also. And initially it is at rest, right? See, they are saying the ring is free to rotate and is at rest initially. So when it is at rest initially, the initial angular momentum will be equal to 0. And when it starts rotating, you will get a final angular momentum, and the final angular momentum will be equal to Q into B A square by 2. It is like m omega square r. So in that relation we are writing it. So Q is equal to L is equal to I omega, and so you can write this equation as I omega is equal to mb square omega, because I is mb square here. So it will be mb square omega. So if I omega is mb square omega, you can write it for omega, and omega will be equal to QBA square divided by 2mb square is the angular velocity equation. So QBA square by 2mb square is the equation. QBA square by 2mb square is the equation. So option A is the right answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.